Hi, this is Prof. Rassi, and this video is on applications of exponential functions. Thankfully, other things grow exponentially besides just the coronavirus. One thing that grows exponentially is when money is invested and then reinvested. The interest is reinvested. This is why rich people tend to stay rich, is they have money, they invest it, and it grows exponentially. I would encourage you to begin investing as soon as you can in your life. You don't have money now, you never will. Start investing soon, even when you don't think you can, and over time it will grow and it will pay back dividends to you. When money grows exponentially, it's often modeled or shown using this equation. A equals P times the quantity 1 plus R over N to the N T, that's NT there. This may look a bit overwhelming, but let's look at just a few pieces of it here. So A is the amount of money at any given time T. P is the principal. Principal is the financial word for initial amount of money. R is the yearly rate given as a decimal. N is... sorry, that's not working so well. There we go. N is the number of compound periods per year. What that means is how often they calculate the interest, and that is calculated at different times. When N is compounded annually, N is just 1. Semi-annually, it's 2. If it's compounded quarterly, it's 4. And monthly, it's 12. And it'll say in the problem how it's invested or how it's compounded. And T is the number of years. So in this first example, it says, suppose that $100,000 is invested at 6.5% interest, compounded semi-annually. It then asks to find a function for the amount to which the investment grows after T years. So we're going to start with this initial equation. A equals P times 1 plus R divided by N to the N over T. I won't ask you to memorize this for a test or anything, but knowing how to use it is important. So it asks to find the function for the amount at any time T. So A is going to be unknown. I'm going to write it in function notation. So A of T equals P. What's my principal? What's my initial amount of money invested? If you said 100,000, you're right. Then I do 1 plus R. R, my interest rate, is 6.5%. But that needs to be written as a decimal. Now, 6.5% means 6.5 for every 100. You can just calculate it with your calculator, 6.5 divided by 100. Or you can just move the decimal point over 2 places, giving you 0.065 for the percentage as a decimal. So that gives me 0.065 divided by N. N, you remember? Compound periods. How often is this compounded? You see it says compounded semi-annually, so that's twice a year, so we need to divide by 2. And then NT, 2 to the T. So this equation here, for any time that you pick, you can plug in T, and it'll tell you how much it's worth. This is really handy, so if I want to know how much money will I have after 2 years or 10 years, I can plug that number in for T. In fact, let's skip to C and find that. A of 0 equals, I plug in 100,000, 1 plus 0.065 divided by 2 times 2 to the 0 power. Now, you might be grabbing your calculator to calculate that, and that's fine. But if you pause a minute and look at it, 2 times 0 is 0. Any number to the 0 power is a big fat 1, and 1 times 100,000 is 100,000. A to the 4. All right, so we plug in 100,000 times 1 plus 0.065 divided by 2 times 2 to the T, which is 4. This one, yeah, it makes sense to plug into your calculator. When you do that, you're going to get about $129,158. How would you like to have an extra $29,000 in 4 years, and all you had to do was invest your money? The hard part is getting that initial 100,000, right? All right. And you can do the same thing for A of 8 and A of 10. A of 8 ends up being 166,817. A of 10 is 189,584. All right, let's graph the function. I'm going to do just a quick aside, a quick note here. You can skip it if you want. But remember we said this is an exponential function? How do we know it's exponential? Well, we know it's exponential because the variable's in the exponent. So even before putting it in your calculator or in Desmos, you know this graph is going to look something like this. Now, it may be stretched out. It may not look exactly like that. In fact, we see there is this 100,000 here is going to be a vertical stretch. So instead of going through 0, 1, like we would expect it to, it's going to actually go through 0, 100,000, which is good because we're starting with $100,000 at time 0. So that should work out if this is time and that's money. All right, let's actually go to Desmos and just type this in. Okay, so if you go to Desmos, I've already typed it in here. You can see I've got y equals 100,000 times the quantity 1 plus 0.065 over 2 to the 2x. But if you look at the graph, you'll notice like there's nothing there. But you remember our initial value was 100,000. So we have to zoom way out to see at 100,000. Here we go. Now, this may not be real helpful because I've zoomed out so far. Actually, I might even do 100,000 yet, am I? Here we go. Now we're at 100,000. With exponential functions, they really take on this L-shaped look. But sometimes it's more helpful to change our axis. So I'm going to go into this little symbol. I'm going to leave my y-axis, but my x-axis, I'm just going to go from -2 so we can see the left side of the graph. I don't know, let's go about 20 years in and see what that looks like. Oh, it changed it. I still can't see it because I'm not at 100,000. It didn't do exactly what I wanted it to. Let me see if I can do that again. Not sure why it didn't adjust like I wanted it. -2 to 20. There we go. So you can see this is what it looks like over 20 years, 100,000, and we see that exponential shape, especially if I zoom out, that we're more familiar with it. But if I zoom in, we get that picture as well. All right, so let's go back to the graph. That's actually probably sufficient as long as we show that it's at 100,000 there in exponential growth. That's probably good enough. Let's go down to Part D. When will the amount of money in the account reach $400,000? Great question, especially if it's my money. There's two ways to approach this. One is with a graph, and one is with the equation. If you focus on the equation, we're actually going to run into some issues. So we know we have this equation, $100,000 times 1 plus 0.065 divided by 2 to the 2t. We don't know what t is. That's what we're looking for, the amount of money we're looking for. When is that going to happen? So that's what it's asking is, what's t? But we want the amount of money to equal $400,000. So when is this true? The problem is we haven't learned how to solve when t is in the exponent. If you think about it, we've used square roots, right? X squared equals 9. We know how to solve those. We know how to solve it if it's just an equation, 2x equals 9. We just divide by 2. But we haven't actually learned what to do when there's a t in the exponent. That's the next lesson. So I'm glad you are wanting to do that. So for now, we're going to have to settle for solving using a graph. All right, so 400,000. Let's look at our graph. Can you picture how this is helpful? If you look here, if we go ahead and just type in y equals 400,000, we can see where this graph meets up with the other graph. And in Desmos, it's pretty easy. I think we can just put our finger there and it highlights it. There we go. Touch it. So when x is 21.672, the equation will equal 400,000. So what does that mean as far as money and time? Well, that means after 21 years, we'll have $400,000. Nice, huh? That's why I'm telling you to invest your $100,000 now. So 20 years from now, you can have 400,000. Yeah, I know. Okay, so time we found from the graph was 21.62 years. All right, so let's do a quick review. We have this handy equation. You need to know what A, P, R, N, and T are equal to. You need to be able to write your rate as a decimal. You need to know which value for n to choose, and then just pretty much plug it in and calculate it. I would encourage you to pause the video at this point and try number 10 on your own before continuing on and watching me finish it. Hopefully you tried that. You'll remember the equation. A equals P times 1 plus R over N times N to the T. You can see here we have our P, we have our R. Here they actually give us the T and they ask for A. I didn't mention N, but you'll notice here compounded quarterly. What does that mean about N? That means that N equals 4. So let's plug it in what we have. A we don't know, so we're going to leave that as A. P is 53,500. Do you have that much to invest? Yeah, me neither. R, 5.5%. We can think of that as 5.5%. Move the decimal over 2. That gives us 0.055 over n, which is 4, to the 4 times t. But in this case, t is 6.5 or 6.5. Once you have that, carefully type that into your calculator, and you should get 76,306. So what does this mean? This means after 6.5 years, we'll have $76,306. And that is exponential growth.